All right, welcome back from spring break, everyone. We are on week 9. We're going to spend a whole week doing some file input-output. All right, input-output means we're going to be reading and writing to and from files. There's a new assignment out. It's called Mad Libs. We'll go over this on Wednesday. But yeah, just one lesson today, pretty much. We're going to finish lesson number 13 today. Number 12 is optional. This one you don't have to do. It's all about character encoding. We're going to skip over this because it's not too important. Pretty much character encoding. I mean, it is arguably important. It talks about how data is represented in bytes and hexadecimal. But for the sake of these homeworks, this one is not as important. So we're skipping over 12. There was an optional lecture a couple weeks ago. It was called Python in Practice. For folks who are moving on to the next class, the intermediate Python, I recommend taking a look at this optional lecture. Right? It's going to help folks out with industry practice and working on future homework assignments in the next class. Pretty much in this class we are exclusively in the Jupyter lab, but in practice most likely you're going to be in a different environment that doesn't have a Jupyter lab. Right, some environments do use Jupyter labs, like scientists, right? Because scientists, they use this lab to visualize data. Right, but as a software engineer, Python in Practice would be in different environments. Yeah, Terrace.
Where's that at?
Where's what at?
The Python in Practice located? Is it located in the Jupyter?
Oh, yeah, good question. There is no notebook for this optional lecture.
Oh, okay. How
Yeah.
can we search?
I have a recording on it.
Oh, okay. Good.
Yeah, so in the recording, we pretty much move away from the Jupyter lab and use a different environment. In that recording, I used something called VS Code. So yeah, you can take a look at this.
Did you record that over break?
Did I record it over break? No, I recorded it a couple weeks ago, like the day after the midterm. All right. Yeah, it's some good stuff. I highly recommend looking at it because, Jupyter Notebooks is not really classic Python programming. All right, let's jump into the today's stuff. File input-output. All right, or another way is reading and writing from files. So this is going to be lesson 13 and lab 13. Before I even open up these, I want to give a sneak peek. As usual, I'm going to load up a Playground notebook and just kind of use it as a scratch pad. All right, so here, let me load up a scratch pad just to kind of play around a bit. So I'm going to go on my Playground. You don't have to do this as long as folks can kind of follow along and get the sneak peek. It's going to be some pretty cool stuff. And for folks who watched the last recording, there was also some nice sneak peeks on this. So I'm just going to create something called file.io. This is just a folder where I'm going to be dealing with stuff. So file input-output. All right, check this out. You might remember that we can create a new file here, right? So lately we've been creating new notebooks, but you can create a new file, right? I'm going to call this test.txt. Right, for folks who are familiar with a TXT file, it's really just a text file, a plain text. Right, so if I open up this plain text file, it's empty right now, but I can write some text in here. Right, this is like a notepad. It's like a word notepad. So I can type in some stuff like this is a test file, and then enter hello world, and then enter. Right, so now there are 2 lines in this test file. Right, we're just gonna keep it super small for now. Let me zoom in. Okay, there we go. Hopefully folks can read that. Whenever we update this, I'm gonna save it. So you see this circle here? This circle means that it's not saved yet. So I'm gonna go ahead and save it. For me, I'm just gonna press Control S. Control S saved it. Okay, cool. Now it's complete. All right, what can we do with this file? All right, there are some Python operations that allow us to interact with files. All right, this is very important for like data analysis and just overall making nice calculations. So I'm gonna open a new notebook here in the same exact directory. All right, so now there is a text file and a notebook file. I'm gonna rename this notebook file just like some sort of file IO. Right, this is just gonna be a scratch pad. Okay, so just to put things side by side, there are two files in this directory. Right, we have the test.txt file on the right, and then we have the notebook here. Right, they're in the same directory. So as a sneak peek into this lesson, all right, we're going to be talking about file input and output. Right, the first one we'll stumble upon is something called input. So we can actually use a Python function called open. All right, so there's a function called open, which takes some arguments. Right, the first argument represents the file we're going to be opening. All right, so let's just say the file we're opening is going to be test.txt. And then there is a second argument. This is kind of optional. I'm going to put it in just to be more explicit. But the second argument typically represents whether or not we're opening it in the input mode or output mode, right? Or read and write. I'm going to open it up in read only mode for now. So I'll put an R here. All right, so this function is going to pretty much open this test file, right? It's kind of like double clicking it. So this command will pretty much double click on here for us, right? And then that's all it's gonna do, right? That's all it's gonna do. It's just gonna open it. Okay. It does return something called a. It does return something like a key, right? It returns like a reference that we can use later. As a common convention, we can call it a file handle. Right, so this opens and it returns a key. Right? We're storing that key in this variable called file handle. Right? You can call it whatever you want. This file handle allows us to perform operations on the open file. Okay, and as a good programming practice, whenever every open should have a close. Right? So, closing means that we're going to be exiting the file. Right, so this file handle.close, this is like saying press the X button here. Right, so it's like saying press the X button, boom, right, closing it. It's a good programming practice because if we open too many files and don't close them, there's a chance that there will be a memory leak. And there's also a limitation. Right, if we open too many files at once, there might be some sort of limitation where you can't open any other future files. So it's a good programming practice to always close, right, when we have an open. And I'll do the stuff in between. Okay, so check it out. It's not going to do anything right now. I'm just going to press play. Right, it doesn't do anything yet. It doesn't output anything. Right, so all it really did was it opened. Right, it just opened like this, boom, and then it closed it. Right, so then press the X and closed. And that's all it really did. This file handle is a key to access this open file. So we can use that key and kind of read some lines. Right, before I read the lines, I just kind of want to show what the file handle is, just so folks are aware of what it is. So I'm just going to print the type, right? The type of file handle. This is going to describe what type of variable this is. So I'll press play. Okay, the type of variable on this file handle is a IO text wrapper. You don't really have to know what this is. It's really just a fancy way of saying a key to a file. We can look at functions, class functions that belong to this type. Right, so I'm just going to go ahead and Google this. Right, so I'll Google IO text wrapper. And right here, right, the first thing that showed up, this is the primary documentation. So I'm just going to look at this right here. Right, we're working with input and output. There are many functions we can do. Right, in particular, we're going to see these functions right here. Right, the first function we're going to see is something called a read line. So let's use that read line function. Okay, so I'm going to delete this. Okay, so read line. So it's a class function, meaning that we're gonna have a period here, file handle dot read line. Okay, so there we go. We just called the function. So I'm gonna press play. Okay, it didn't output anything, but it did do something. Right? It did read one single line. It's just that we didn't capture it. Right? So this function does return a string. Right? If we look at the documentation, right, read line, this does read and return a string, right, a one-line string. So let's go ahead and capture that string. Right, I'm going to capture it in a variable called line1. Okay, there we go. So we captured that variable. I'm just going to print it. Right, let me just print it saying line1 is, and then I'm just going to interpolate the string into here as a f string. Okay, so now let's press play. Okay, cool. So folks kind of see what happened here. We read a line, right, stored it in this string, and then now it's saying this is a test file, which makes sense because our text file, the first line does have that string, right? So it's reading this very first line. We can do this over and over again. Right? We can go ahead and read the next line. Right, so I'll say line2 is equal to file handle dot read line. All right, there we go. So we got two of them. So if we print out the second one, let me just copy and paste this. Line2 is line2. Okay, so now I'll go ahead and press play and press, there we go. There are two print statements now, right? They're really just outputting the same exact thing in this test file. And then after we output it, we close. It actually might be better to put the closing operation before the print statements, because typically we want to close it as soon as possible, right? Well, you know, here we're pretty much done with the file because we're done reading all the lines. All right, but here let's kind of see what happens if we read more lines. All right, like let's just say line 3 is equal to file handle dot read line, right, and print that out. Right, there's nothing in line 3, so we should see nothing here. Right, yeah, this makes sense. There's nothing in line 3. Let's do it again with line 4. Right, so line 4. Okay, copy and then paste. There should be nothing in line 4, right? Plus, line 4 doesn't even exist in this file. Right, but let's see what it does. So I'll press play, and there we go. Yeah, we see there's nothing here, right, which totally makes sense because it doesn't even exist. So hopefully people kind of see what's happening, right? The read line is kind of seeking through the file, right? This first one seeks through the first line, and then it goes to the next one, so we can read it. Right, for folks who are curious about what seeking means, you can think of it as a cassette tape, right? If you're seeking through a cassette tape, you're kind of going ahead. Right? So this is doing two things. It's grabbing the data and it's seeking forwards. All right. And yeah, you might be wondering why there's an extra line here. This is pretty much because this test file already has a new line, and then the print statement adds another new line. So that's why there's this extra white space here. Okay, let's see. Let's move on. Are there any questions about this so far? Just some reading lines.
Yeah, so I got error 2, no such file or directory test for the test one. How do I put the test text into the same file?
Yeah, let me see. Someone got a no such file. Let's see. I mean, there's a few reasons that could be. One is.
At least because my it's not in the same folder.
Oh, okay.
As the
Oh, which folder is it in? Oh yeah, you need the test.txt. So this is the test.pynb. Oh, okay.
No, that's not. That's what's in the folder.
Oh, okay. Yeah, I wonder where it is then. We save it somewhere.
random text.
Yeah. Okay, so there was a question earlier about a file not found error. There's a couple reasons for that. One is we're assuming that the file is in the same folder, right? It's adjacent to the same folder as this notebook. Another reason is if we misspell this string right here, right? Like if I were to say capital T, right? Capital T, there's some case insensitivity going on here. So if I press play on this, it's going to give us a file not found error. All right, so this makes sense because this file doesn't exist in this directory. So yeah, just a couple of reasons. Right now we're assuming that it's in the same directory. Okay. Are there any other questions about reading lines? Yeah, George.
For the print type file / handle, do I delete that?
Oh yeah, I deleted that earlier.
Okay.
Yeah, so earlier we had a print type. I deleted that just so earlier we had print type of file handle. And yeah, I just deleted this. The only reason why I was printing out the type was just to kind of visualize the type of variable. And it turns out that the type of variable is called an IO text wrapper. So the only reason why I printed out the type was to look up the documentation over here.
Oh, okay.
Yeah, good stuff. Someone go ahead and delete this. Let's see. Someone in the chat says we did something similar to this in the Linux class. Yeah, in the Linux class, you might have done some directory things, right? Like maybe you might have worked with something called a relative directory and something called an absolute directory. We'll talk about those later. Pretty much, a relative directory assumes that we're working from this folder right here, right? So it's assuming we're working relative to the file input output. But there is an absolute directory as well, where you can specify files in other folders. Right, so there's yeah. If you took a Linux class, then you might understand directories and paths. Okay, let's kind of move on. Read line. Okay. Let's see. What else should we do? Okay. So yeah, this is input, right? We're inputting from a file. This is useful for, like I said, data analysis. Right? In the real world, a lot of jobs are taking files, analyzing the data from it and producing some sort of output. It's kind of like how machine learning works, how AI, artificial intelligence work. It's reading from files and then calculating some stuff from it. Okay, let's do another type of input. Oh, in the future, we're going to be looping this, by the way, right? This might seem kind of cumbersome, like we're typing in read line 4 times. We haven't learned about loops yet, but yeah, in a couple of weeks, we'll see how to loop this. There is a cool way that we can kind of compress this without a loop, right? There's a really cool way. Pretty much, here, let me declare the same exact file handle, and then I'm going to open up the same exact folder, file, I mean. So I'm just going to open up the file. It's called test.txt, and I'm going to open it up in read-only mode, right, meaning we're not expecting to change the file. Right, so I'm just going to open it, and as a good programming practice, I would close it. Right. Right. This way we don't have too many open file handles at once. Okay. There's another really cool thing we can do. Earlier we had to read 4 different lines, but we can actually do a list conversion. Right? We can convert this file handle to a list. Right? So I just wrapped it in a list and then parentheses. Right? This converts this file handle to a list, right? And it's gonna be a list of strings, so I'm gonna store it as lines. Right, so just so folks kind of see what's happening, right? I'm gonna press play on this. Right, it didn't look like it did anything. That's because there's no output. So I'm gonna print out the lines. All right, lines are, and then I'm just gonna put lines here, just so we can visualize what's the conversion. Okay, so press play, and there we go. So we kind of see what happened here, right? We converted a file handle to a list, and this list has two elements. All right, so first element is this first line, and the second one is the second line. All right, and then there are new lines here. All right, /n. This is another way of saying new line. Right, new line means go to the next line, which are technically right here at the end of each one. Okay. Let's see. So yeah, you can do some really cool stuff with this. Like since this is a list, you can index multiple positions, right? Like if we wanted to access the first element, we can just say line 1 is, and then we can index the first element in that list, which is a 0, right? And then similarly, we can grab the second one. Line 2 is the next element right here. All right, so there we go. And yeah, see, it's just indexing the list. Okay. And you know what? It might make more sense to close the file handle a little earlier, because technically we're done after converting. Right, so technically we're done with the file handle here, so it might make more sense to close it a little earlier, because we're done with it. Right, because we stored all the lines in this list. Okay. All right. So yeah, all we really talked about was a function called readLine, right? We'll see another one later. In the lesson, we'll see something called a read, where it pretty much grabs everything from the file. Let me look it up real quick. Yeah, there's another function called read, which pretty much reads the whole file. We'll see this later. But for our case, read lines will be the most useful, especially for the next assignment. Okay, so let's talk about output now. We just talked about input, which is reading from a file. So I'm going to quit this test.txt file now. Here's some really cool stuff. Right, the opposite of reading is writing. So we can actually do the same exact thing, right? Like open, right? What if I opened a file that doesn't exist? Right? For example, I'm just going to call this file test output.txt. Right, so this is not going to exist, right? Like if I try to open this, it's going to give us a file not found error, right? Which makes sense because it doesn't exist here. Right, and by the way, I didn't specify the second argument, r, because that's actually the default flag, read. Right, so it's just going to give us file not found error. Now, but check this out. If we do a w means write, right? Meaning that if it doesn't exist, we're going to create it. Okay, so as a good program practice, I'm going to close this file handle as well. Right, this way we don't have too many things open at once. So I'm going to store it as a file handle and then close it here. All right, make sure to close it, otherwise it's not going to write the file. Okay, so check this out. We're going to open something that doesn't exist, and boom, press play. Okay, this didn't exist, right? But now it does. Right, you see on the left, there is a new file called testoutput.txt. Right, so people kind of see what's happening here, where it didn't exist, so it created it. Right. So yeah, we can do this with any files. Be careful with this, by the way. Be very careful, because if you're opening up a file that already exists, it's going to clear everything. So yeah, be careful with this. Okay. So this test output is empty, right? Like, let me pull it side by side, just so people kind of see the contents of this file. All right, here's the test output.txt. There's nothing in it, right? We can write stuff to it, right? The opposite of reading is writing. So we can do a file handle dot write. Right, this is the opposite of read, and we can write something in here, right? Basically, the argument here is whatever we're putting into the file. Right, so we could put, I'm just gonna hard code a string here, like testing. Right. Okay, testing, and I'll press play. Okay, so I just ran it. Right. This got changed. We have to refresh it. We have to refresh this file. So I'm going to quit this over here. Right, quit this file and then reopen it. We should see a change. There we go. Just had to refresh it. So there we go. All right, we see that it opened up a test file and it dumped some contents into it. Right. Okay, hopefully people are cool with this. So we can write some more stuff to it, right? Like file handle dot write, and then I'll put hello. All right, let's see what this does. Once again, when we open up a file in write mode, in the W mode, it's gonna clear everything. Right? It's gonna clear everything in this test output, right? And then we're gonna rewrite this stuff into here. So I'll go ahead and press play. Boom, press play, and then refresh this file. Right, there we go. And then people kind of see what happened here. It says testing, and then hello. Right, all on the same line. Right, so yeah, writing is different from print statements. Pretty much the print statement adds a new line for you, but a write function doesn't put in a new line. So I mean, we could do that manually by doing a /n here, /n, and then let's rerun this. So I'll rerun it. Okay, so I just reran it. Let me refresh this file. So boom. There we go. Yeah, now they have new lines. Okay, so yeah, once again, we wrote a file, and I do want to reiterate that opening something in write-only mode will clear the contents before writing. Right, so be careful with this because you could possibly lose data just by opening a file in write-only mode. For folks who might have taken a Linux class, you might be familiar with logs. Right, logs are files that get bigger and bigger. We can open up this file in append mode. Right, you're not going to need to know this. This is actually additional information that I don't think folks really need to know, but there's a append mode. It's A, right? If we use A, this is like opening the file but not clearing it, right? Instead, it's going to add to the end of the file. Right, so append. So I'll run it, and then let me refresh this. Test output. There we go. You see how it appended? So if I run this again, right, let me run it like 5 times. I'll run it 5 times. So press play again, press play. I'm just spamming it. Okay, so we just opened it up in append mode every time, meaning that it's going to add to the end of the file. All right, so just in case folks want to do something a little safer, where like maybe you don't want to clear the contents before writing, right, if you're opening up in append mode, it won't clear it. But for the sake of this lesson, we really only need to know about the read and write. So if I use a W here, right, and rerun this cell, it's going to clear the contents and then rewrite everything. Right, so let's try it. So I'll press play. Then let's refresh this file. There we go. See, it cleared out everything, and then now we're starting back with 2 lines. All right. So yeah, that was a sneak peek. Right. All we really talked about was reading and writing. Are there any questions about the sneak peek before we move on to the lesson?
Did you like hard for like that list of the testing, hello,
Mm-hmm.
and it was repeating like 1 through 15. Did you type that or did you generate that
Oh, that was generating.
from the cell?
Yeah.
Yeah.
You don't really need to know too much about it, but earlier there was append. Right? Append means to not clear the contents. It's just going to open it up, not clear everything, and allow us to write stuff at the end of the file. Right? So if I just use the A and then just spam this a bunch of times, there you go. I just ran it like 10 times. So I ran it like 10 times, and it's not going to clear it.
Okay.
So it's just going to append.
Yeah, okay,
Yeah. This is append mode is good for writing log files. But yeah, for now, W.
the dash in. What is that referring to?
Oh, the /n.
Yeah, the force.
Yeah, this is a new line.
That refers to new line.
Yeah,
Okay.
yeah. /n is a new line. If it weren't for the new lines, then it would write it on one single line. So I just removed the /n.
I got you.
Yeah, it's a little different from the print statement. Like basically when you do a print statement in Python, it'll automatically do a new line for you. But with this write function, it doesn't do a new line. So we kind of have to explicitly put a /n here. Right, like if I put more /n's here, like new line, right, this is it's gonna put a bunch of vertical white space. So there we go. Yeah, see, bunch of new lines, and then hello. Yeah, some good stuff. Pretty sick sneak peek, right? File input output. Yeah, this is some really good stuff. Okay, let's move on to the lesson. There's going to be a lab associated with it as well. So let me open up both of them. So lesson number 13. All right, we're skipping over 12. Okay, here we are. Lesson number 13. And then also the lab. Okay, lab number 13. Okay. I'm just looking at the lab real quick. Okay. Okay, here's the lesson right here. We're gonna go back and forth as usual between the lesson and the lab. Okay, let's see. Reading and writing files. I guess one thing we forgot to talk about earlier. Do folks know the difference between memory and storage? Right, what's the difference between memory and storage?
Do they like get saved to two different places?
Yeah, they're in different places. Right, there's memory. Like if you look at your computer specifications, you might see that there's like 16 gigabytes of RAM, and then your storage is like a lot bigger. Like maybe you have like 512, or maybe you have 1 terabyte of storage. All right, the difference between memory and storage, memory is kind of temporary. Right? It's temporary. It only exists when our computer is powered on. Right? But storage exists when the power is off. Right? So that's where the files are. So all of these files here on the left, right? These are stored in the storage, right? Meaning that if we turn off the computer, they're still going to be there. On the contrary, the memory, right? Memory, this is like a short-term storage, right? Which stores variables, right? Like if we say like x is equal to 5, right? I'm gonna delete this in a bit. Right? X is equal to 5. This is creating a variable that's storing 5, right? So I'll press play, and then let me just print it real quick. All right, this is it's stored in the memory, meaning that if we turn the computer off, right, this x no longer exists, and we're gonna have to rerun this cell to load it back into memory. So anyways, the reason why we're talking about the difference between storage and memory is because we're talking about files. Right? We're going to be working with opening things in our storage. All right. I want to talk about paths. All right, file paths represent the location of certain files. Let's talk about relative paths right now. All right, relative path means that we're adjacent to this same notebook. So this notebook is located in the lessons directory, right? So I'm going to go to lessons directory. Right? We can open up this path right here, right? This path contains two names, right? Images and then Python list. And so this path is relative to this notebook, meaning it's going to look for this image folder, right? Which is right here, right? So it's gonna go into this image folder and then look for a file called pythonlist.png, which is right here. Right, so people can see what's happening. We're relative to this lessons directory because that's where the notebook is located, and we're able to load it up. Right, it's just a picture. Right, it's just a picture that we use in one of our notebooks. So this is called a relative directory. Let me comment it. Relative path. Right, it starts from the location of the notebook. Okay, there is an absolute path as well, which we'll do later. This is another relative path, by the way. For folks who have taken a Linux class, you might be familiar with this dot dot. Dot dot means to go backwards. So if we start from the relative directory, right, we're starting from the lessons because that's where our notebook is located. Right, we can go backwards. Right, so let's see what happens if we go backwards. So I'll go backwards, boom, okay, and then now it's going into this labs folder. All right, labs folder is right here, so I'm gonna double click into here, okay, and then there's another folder called files, so I'll go into here, and then finally a file called maze.png, and here it is, right, so this is gonna open up that file, the picture file. Go ahead and run it, and yeah, it's just gonna load this up. Right, so this is another relative path, right? It's starting from the lessons notebook, but then the lessons folder I'm in, and it's going backwards, then it's going forwards and forward again. Okay. Let's see. It is possible to do an absolute path as well, because it might be kind of cumbersome to say, oh, dot dot, right? Because sometimes we're not sure how many times we got to go backwards. I don't think you really need to know too much about absolute paths, but if you're curious, let's see the path for this notebook. Right, so the path for this notebook, it's a little off topic, but I'm gonna load up a bash terminal. Right, if I do an ls, these are all the available files. I can type in real path, and then the one that we're working with is called lesson 13 files.ipynb. Press enter. Right, the absolute path is here. Right, it starts with a /, and then at the home directory, and then Jovian. Right, this is just something that was created for the lab, and then these ones folks might be familiar with. Right. So let's do the absolute path real quick for this maze. Right, this is not absolute; it's relative, meaning that we have to go backwards and then forward. Right, so once again, you don't have to know this stuff, but the absolute path, we can kind of infer it from here. Right, like the first 3 folders starts from /home, and then these things right here. Right, Jovian and CS15. So I'm just going to copy this. Whoops, didn't mean to press that. So I'm just going to copy right here. Okay, there we go. Copy. So the equivalent way of writing this is with the image.open and then the absolute path, all right, which starts at home, and then when we're inside the CIS15 directory, we can go into the labs, and then the files, and then the maze. All right, so this is the absolute path. It pretty much starts from the root. Right, the root is home. So yeah, these two are the same exact thing. I'm just gonna run it. Yeah, see, same thing. Okay. All right. So yeah, that's some good stuff about paths. All right, let's talk about reading files now. All right, we already did this in the playground, so this is gonna go a little quicker. All right, file handles. It's like a key, right? Like if we were to open up a file, right, in this directory, right? So let's deal with this one here, right? Let's pretend that we're inside this relative directory. We're gonna go inside of files, and then example.txt. Right, this is just a random folder. I mean, random file. So let's use that. So I'm gonna open it with open files, which is the folder. Right, so it's going to click into there, and then example.txt. Okay, and you don't have to do this second argument, read. Right? It's actually going to do a read by default, but I like to be explicit, so I'm just going to put it in here anyways. Right, so this function does return like a key. Right, it's like a reference that will allow us to operate on the file, right? And you can store it in whatever you want. I'm just going to store it in something called file handle. Right, you can call it whatever you want though. Okay. Yeah, so it's going to store the file handle, and well, one thing that this notebook doesn't go over yet is the close. Right? It doesn't talk about the closing until the bottom of the notebook. So I'm actually going to close it later, as long as folks are aware that we have an open file handle. So be careful with that. So yeah, open, boom. Okay, I just ran this cell. Right, it didn't output anything, but we do have a variable loaded now. Right, it's called file handle. So we saw earlier that if we print the type of it, right, this is the type of file handle. Right, file handle, boom. Right, this is just describing what type of variable it is. Right, a good reason for looking up the type is so we can look up the primary documentation. Right, like if we were to look at the documentation for this IO wrapper, right, we saw earlier that it leads to primary documentation right here. It is a little dense to read right now, but it does tell us the functions, the class functions that are available to this. Right, and so far we've been using the function readLine right over here. Yeah, we use this function readLine. We use another function called write right here. Yeah, and that's pretty much it. And then close as well. Where is it? Right here. Yeah, we use a few of them. So yeah, sometimes it's good to look at types. Alright, let's see. I'm actually going to close it. This notebook forgot to close it. So it's kind of like an open file handle. You can consider it like a memory leak almost. But yeah, I'm going to close it. Just the file handle.close. Just to close the handle. Good programming practice, right? Every open must have a close. Otherwise, you're leaking a handle. Right. Okay, let's reopen it. Okay, so we closed it. We're going to reopen the same exact file. Right, it's inside of this folder, and it's called example.txt. All right, so let's open it again. Boom. Okay, I just opened it. And yeah, we saw what readLine did earlier, right? ReadLine does two things. Right, it grabs the line, and then it seeks forward. Right, so the notebook is going to show us the result of the value of this last run cell. So if I run it, it's going to say this is example.txt, right? So that's the return value from here. And then I can keep running it over and over again, right? Because we seeked forward, right? So here, let's kind of see what example.txt is. Okay, I just opened up this file, right? There are several lines here, so I can rerun this cell. I press play, and then now we seeked forward to this next line, and I can run it again. All right, violets are blue. Now we're on this line, right? And then seek forward. And there we go. Press play one more time. There we go. See, we're at the end. Right? And if I read it one more time, there's nothing. Right? Which, yeah. So we're done reading. Okay. People cool with this so far? Just reading lines.
Yeah, but the example.txt, did you generate that file yourself or is it already?
Oh yeah, this example.txt is already in our folder. I never generated it.
It's in lessons.
Yeah. It's in the lessons, and then it's in the files, and then example.txt. Yeah.
Definitely open it up first.
Oh, it's all good. Yeah, it shows right here too. The location of it is right here.
Okay.
Yeah, relative to the lessons notebook.
No, yeah, like I had opened the folder at first with like all the math names and everything. I just
Yeah.
did not see example all the way at the top.
Oh yeah. Yeah, there's a bunch of files. So yeah, we're gonna have to organize our things a little better.
Yeah.
All right. Let's see what else. Okay. This next function we haven't really seen yet. It's read. Right. Pretty much this is just going to grab every single thing. I'm not really a fan of this function, but here, let's run it. All right. So I'll run it. It doesn't print anything yet, which the reason why it's not printing anything is because our earlier cell seeked to the very end. All right, so we seeked, and now we're at the very end. So when we read, there's nothing else to read. Let's start over though. All right, let's reopen the file handle. All right, and then start from scratch. All right, so I'm going to run this cell again. There we go. I just ran this cell. So I'm going to skip this read line, right, and then go down here. Just read the whole thing. There we go. We see that the read function, right, it grabs everything from where we start, right, all in one single string. So I'm not really a fan of this because if our file is really large, like let's say we have a 1 gigabyte file, then that means there's going to be 1 gigabyte used in the memory, right? So this is, I'm not really a fan of this one because we loaded too much. I'm more of a fan of doing it kind of one at a time, right, one line at a time. This way we don't use as much memory. Okay, let me just play that again. Let me restart. So let me clear this output. So check this out. We can do things in different orders. Like if we reopen this file, right? Reopen means we start from the beginning. All right, let me read one line. All right, I'll read one line. So there we go. This seeked forward, right? It seeked forward, so now the file handle is pointing here at the second line. So if we start reading everything from here, it should grab everything from there. Right, so I just read it, and it grabbed everything after. All right, roses are red. So yeah, just so people kind of see the difference between read line and read. All right, read grabs everything from where we last seeked at. Okay. Let's see. Let me see if we have enough to do the lab.
What shortcut are you using to open up the example text?
Oh, what shortcut am I using to open up the example text?
Yeah.
I just dragged it to the right. So I just drag this file over here and then kind of split screen it so we can kind of visualize it.
No, yeah, I do that, but mine doesn't like.
Oh, just
Doing it right, or is that just like another way to split it?
yeah, you could split it horizontally too.
It's the same thing.
Yeah, but I mean, you can just drag it over to the right like this. So you're just clicking and dragging windows.
Didn't know mine's. Oh, okay, I got it now. Cool.
Okay, let's see. Let me see if we have enough to do the lab. Not yet. Okay, let's do a few more things. Okay. We almost have enough to get the first part of the lab done. Okay, let's see, where are we? Okay. Okay, yeah, let's... Yeah, well, once again, we did this in the sneak peek already. We can read lines individually. Like if we reopen the file handle, I'm just gonna reopen it. Files, example.txt. You don't need to do this R, but I'm gonna do it anyways, just for safety reasons. Right, we can read lines individually, right? Like file handle dot read line. Right, and there are like a lot of lines in this. Let me see how many lines there are here. 1, 2, 3, 4, 5. There's 5 lines. So we can actually do 5 read lines and then store them in different variables, right? Like line 1 is equal to this. Alright, line 2 and line 3. Line 4, line 5. All right, and just real quick, we should close it because, you know, by this time we're done with the file. There's nothing else to read. So it's a good programming practice to close it. All right, exit the file. This way we can use it again later. Okay, so we grabbed the 5 lines and now we can print them. All right, so I'm just gonna print them. And then press play. See, there we go. We're at lines, and then it printed the very first line, and the new line, and then these next 3 ones. Right, 2, 3, and 4. Right, let's get the 5th one in real quick. Line 5. There we go. Rerun it. Now it's printing everything. All right, all 5 lines. Okay, let me put a new line in this, just to make things look a little neater. So new line. This way everything is actually on separate lines. Here we go. Looks nicer. All right. Okay, let's do a shortcut and move on to the lab. So this was a little cumbersome, you know, reading one line at a time. Right, it is possible just to convert the file handle into a list. So if I reopen the file handle, right, so file handle open, let's do the same exact one, files.txt in read-only mode. Once again, you don't have to do this R. It's already there on default. And here, let me close it real quick. File handle.close. We can convert this file handle using a list conversion syntax, right? Where we do list and then parentheses, and whatever we want to convert goes inside. All right, so this will convert it, and it's going to return list that we can store in this variable called lines. All right, so there we go, and then we can go ahead and print it. All right, print lines. All right, we'll see that, yeah, just a list of like 5 items. All right, 5 strings. And we saw this in the sneak peek earlier. This is a very, very nice. I'm still not too much of a fan of this. I come from a data analysis background, where this is kind of inefficient. Because if we have like, let's say we have 1,000,000 lines, right? If there's 1,000,000 lines, then the list is going to get very large, and it's can be considered inefficient because then you have 1,000,000 lines loaded into memory. But yeah, for this class, I don't think we have to worry about efficiency too much. But if you're dealing with data analysis, it's probably not a good idea to load the whole file, because this could be this could be gigabytes large. Okay, we're done talking about reading files. Let's do the first couple in the lab. So the first couple questions here in part 1. Okay, so here I'll help folks get started with it. This is actually in a different directory, so make sure to kind of navigate to the right directory. Right, this lab is located over here. Right, so make sure you open up the right directory. This way you can kind of visualize that the relative paths. We should be able to do 1 and 2. Right, number 1 is asking us to create a file called test.txt. We actually did this in the sneak peek already, but yeah, go ahead and try it again. Right, just make sure you're aware of where this file is located. Right, some folks might need to kind of clean up their directories and rearrange things. But yeah, make sure you're in the right directory. I'm here in the labs. So yeah, go ahead and see if you can do number 1 and number 2. Right, and for folks who want to get ahead, you can probably get 3, 4, and 5, and 6 done. But yeah, for now, just see if you can get number 1 and 2 done. Let's give it like 10, 15 minutes. Okay, nice work, folks who got the first 2 done. Right, there's no need to move on to number 3, number 4, and those yet. We really barely touched on writing a file. Right, so let's reiterate writing a file before we go into it. But for now, let's just get the first 2 done. So the first one asked us to create a file called test.txt. I saw some folks were using Python to create this file, but let's assume that we didn't learn how to write yet, meaning that we should manually create this file. All right, so I'm going to manually create it. It's up to you where you want to put it. For me, I'm going to put it inside of this folder. Right, inside of this files folder, and then make a new file here called test.txt. Right, you can put it wherever you want as long as you're aware of the path that goes to it. Okay, and then write a few lines in it. So yeah, some people use Python to write it, but we're expected to just do it manually here. All right, so I'm just gonna write some random lines. Roses are red, violets are blue, and then something something. Enter. Cool. Now we got 3 lines. Don't forget to save it. So I press Control S. Now it's saved. Okay. Now we can go ahead and read and print the first line in the file. All right. So we need to open up that test.txt. Right, so I saw some folks got a file not found. That's most likely because your open wasn't opening the correct directory. So when we open, right, the first argument is the path. Right, the path is, if we're using a relative directory, then it starts from wherever this lab is located. Right, the lab is located here, so relative to here, we're going to go into files. Right, so it's inside of files, and then /, right, /, and then the name of the file we're looking at. Cool, there we go. That's the path to this file. Right, and once again, you don't have to open it in read-only mode. I'm gonna do it anyways. The default behavior. Right, and then store it in a variable called file handle. You can call this variable whatever. Okay, so that's gonna give us access to do operations on a file. As a good programming practice, make sure to close the file handle. Otherwise, we're leaking. Leaking files. So there we go, and then we'll do the stuff in the middle. Right, all we really need to do here is read and print the first line in the file. Right, so we saw one function earlier. It was called the read line. Right, read line. There we go. Right, this does 2 things. Right, it grabs the first line and seeks forward. All right, so it does return a string, so we could store it in some string here. All right, so line 1 is equal to file handle.readLine, and then let's print it out. All right, so print out line 1. Oh yeah, there we go. Roses are red. That's the very first line. Right. Oh, you know what? The next one asks us to print the first 2 lines. So we can actually just get by copying and pasting this, right? We can get by copy and paste this and then just grab 2 lines instead. So line 2 dot read line, and go ahead and print line 1, line 2. All right, same thing, just with an extra read line. Okay, let's do it another way. Someone earlier brought up how to involve lists. Yeah, we can actually use lists here. Here, I'll make another text box just to kind of show a different way. So in the first one, an alternative way is just to convert the whole file handle into a list. All right, so I just made a new cell. Right, we could do the same exact thing. All right, I'm just gonna, let me copy this actually. All right, and then close it for good program practice. All right, another way we can do this is by converting this file handle to a list. Right, there's a list conversion syntax where we say list, and then we put whatever we're converting. So here I'm converting file handle, and then this does return a list. So I'm going to store it in a variable called lines. All right, so lines is a list. Right, if we print the lines right here, right, you see how it prints out every single thing in the file. For this case, we really only need the first line, so we can index the very first element with this 0. All right, so instead of printing the whole list, now it's just going to print just the very first element. All right, so same thing, right? It's whatever your style is. I'm more of a fan of this first style because it's a little more memory efficient if you're doing things one at a time. Okay. Similarly, for the second one, let's do that same exact thing, right? So it's going to create a new one, create a new cell, right? So instead of printing out the very first one, we want to print out the second one as well. So same thing, but printing out the second line. So I'll go ahead and run it. There we go. Right, same thing, just a list syntax instead. Okay, so we just did the first 2 in the lab. Let's go back to the lesson, finish talking about writing files, which will give us enough to do the rest of part 1. Okay. So we kind of already talked about writing files, but let's do it again. Okay, I'm going to switch back to our relative path. All right, we're inside of the lessons directory. Right, so just to be aware, we're inside of here with the lessons. Let's create a file using Python. Right, earlier we created it by kind of right-clicking here and then saying new file, but you know we can do that in Python. Right, but basically we can say open, but in the write mode. So if we open up something called output.txt in write mode, right, this doesn't exist in this directory. Right here, let me look at it. So, oh, it actually does. I'm gonna delete this real quick. This was from my last year, so I'm just gonna delete this real quick. Okay, so this output doesn't exist, but when we open it in the write mode, it'll create it. Right, and then I can go ahead and store it in a file handle so we can have access to it. Okay, so when I press play, right, I press play, we should see a brand, actually no, not yet. Oh yeah, here it is. Here it is. See, here it created a file called output.txt and it was modified just now. Right, that's what this line did. it is empty, right? It's currently nothing in the file. So let's write some stuff to it. Right, it's kind of like printing. So we can use the file handle dot write, and then just you can put whatever you want in here. Hello file world. And then I'm gonna put a new line here because once again the write function is different from the print. Right? It doesn't put a new line for us. So I'm gonna put a new line manually, and then press play. Okay, it does say 18. All right, we'll talk about this in just a bit. Pretty much 18 just represents how many characters we wrote into the file. But let's see if this file was updated. So I'm going to refresh this. So refresh, and then go into output. Okay, there's nothing in the file yet. That's probably because we didn't close it. So the changes aren't really saved until we close it. So I'm going to go file handle.close. Okay, now let's rerun it. So rerun it, and it should put it there now. So let me look at output. I had to refresh the file, and there it is. Yeah, it wrote it twice. Right, it wrote it twice because I ran the cell earlier without the close, and then I reran the cell with the close. So that's why there's two of them. Okay. Let's do it. Let's see. Let's do it again with a different output. So let's say we had a variable called name, a string variable. I'm just gonna say Andrew space tac. Right? We can write variables into the files as well. Right? So we could do a file handle dot write, and then hello, an f string, right? Hello, my name is name, and then new line. Right, this is probably going to give us an error because this file handle, we actually closed it earlier. Right? If you remember, our last operation was closing the file handle, so this will probably error out somewhere. So here, let me press play, and then yeah, it says error. Right, it says we're trying to write to a closed file. So maybe we could open up another file and then write to it. All right, so let me open up another file. I'm just going to call this one greeting.txt, right, a brand new one, .txt and W for write-only mode. And don't forget to close it too. File handle.close, otherwise it won't save the changes. Okay, let's try this now. So I'll press play. Okay, press play. There's no output, but there should be a brand new file here. There it is. See, greeting.txt. And if we look at it, it should show up as just that single line. Hello, my name is Andrew Tack. Okay. Cool. So yeah, and then we already talked about closing the file handle. Pretty much this is important for a couple of reasons. One is if we don't close it, then there's a chance that you'll have a lot of leaking file handles. And then second, if we don't close the file handle, then the written changes won't show up. So that's why it's good to close.
Do you mind if you just like scroll up for like 10 seconds?
Yeah, I can scroll up a bit. You're all good? Okay, cool. We're pretty much done with the lesson, actually. We talked about reading and writing. The rest of the lesson is getting into fancier data types. File types. Right, so far, we've only been dealing with plain text, right, like a TXT file. But you can open up other things too, right? Like we saw pictures, right? Like a PNG. This is a picture file. You can open up music. You can open up tables, right? CSV, this stands for comma separated values. If you're working with data analysis, a lot of data is organized in comma separated values. All right, but for this class, we really only need to know how to deal with text files. Right, all of these are other fancier stuff. And you can see down here that these are optional stuff. You don't have to know about it too much. This is just using a library. Right? It's called a Python image library to open up different things. Right? Like if I were to try this one out right here, so I just pasted this. Right? This is gonna go to a different directory. Right? It's gonna go backwards. Right? So let's see what backwards is. Right? It's gonna go backwards, and it's gonna go into labs. Right, labs, and then files. It's going to go into here, and then maze.png. Right, so this is just going to show that image. This is not a text file; it's a picture file. Similarly, we can look at what's this? A wave file. Right, this is a audio file. Right, that's relative to our lessons directory. So let me go back to the lessons directory. All right, so this is going to go into files, and then it's going to access Conga Groove. All right, so we can open up a MP3, a wave file, and then if you press play on it, it should play it. There you go. Yep, so we can open up multiple types. And then in a few more weeks, we'll do some data analysis, right, with files called CSV, right, which means comma separated values. So you don't have to worry about this too much. We'll talk about it in a few more weeks. But it's pretty much loading a table, right, a table of data in the Major League Baseball. All right, so these are just some fancy stuff. But for now, we just need to know how to use text files, right, the TXT. With this very first row here. We should have enough to get the rest of part 1 done now. So there's like 15 minutes left in class. Let's see if folks can do this. So here, I'm going to go back to the lab. All right, so let me go to lab, and let me switch to this relative directory. So we are here in this labs directory. The rest of part 1 is asking us to use Python to write a file called fish.txt. Right, so it's going to have us write 4 lines into a brand new file. And then the next lines, the next cells are just asking us to read from it. Right, so yeah, number 3, right, it's asking us to create a file called fish. Don't do it like this way right here where we right click and then new file. This question was intended for us to open. All right, so here, I hope folks get started on it. So for number 3, we want to open a brand new file called fish.txt. Fish.txt in a write mode. Right, and to be a little more organized, let's put this inside of this folder. Right, let's make it go inside of this files folder. Right, so I'll put files here and then /. Right, this way we can be more organized on where our files are. Cool, so once we do that, and then I'm going to store it in a file handle variable. And once again, don't forget to close it and do the stuff in the middle. Right, so all this is going to do, right, I'm going to press play. Right, there we go. I pressed play. All I did was it created a file here. Right, see fish.txt. This is brand new. Right, there's nothing in it yet. But if folks get this question done, there should be 3 lines in there. Right, so see if you can write those 4 lines. And once you get that done, the next questions are asking us to reuse that file. Right, all it's asking us to do is read the file and print them. Okay. So yeah, go ahead and give it a shot. We have like 15 minutes left in class, so we'll use that remaining time to get it done. I don't think there's going to be enough time to go over it, So try it out yourself, and on Wednesday we'll jump into the rest of this lab. You could probably try to do part 2 by yourself. I would highly recommend trying out part 2 yourself before we visit it. On Wednesday we're gonna get through part 2 and then give some hints on the next assignment. Okay, so I'm gonna stop the recording here, and if there's enough time I'll go over this.